Hey kiddos, here's the spiral review for spiral 23. I'm going to start off, and I didn't label these video or non-video, so I'm going to try to do the first problem of each type. And the first thing I'm going to do is take a look at log properties. When I look at this, I've got to do this in a couple steps. And the first thing I see is that we've got some coefficients here, the 7 and the 6. And the very first thing that I'm going to do is to bring those up as powers and rewrite this as log 4 plus log x to the 7 minus log y to the 6. One thing that I'd like you to know is that if you don't have a base on a log, it's log base 10. We call this the common log. But you don't have to put your own base in there. That base is already there. It's just written without it. It's the most common one that we use. The next thing we do is write one log statement. And the way that I like to build these is that anything that's positive, so these first two terms are positive, I'm adding, that turns into multiplication. Those go on top, so we got 4x to the 7. Anything that's negative, subtracting is going to turn into division. That's going to go on the bottom, so it's y to the 6th. In the next section, we're going to go the opposite direction, and we're going to be expanding. So I'm going to start off by doing the opposite thing we just did. And I notice that we've got two different things on top, one on the bottom. So this is going to become log of 3 plus log of x squared minus log of y to the 5th. And then I'm going to bring the powers down for the two that have powers. And that becomes log of 3 plus 2 log of x and minus 5 log of y. Okay, moving on, we've got solving using common bases. And here we've got 9 to the x plus 1 and 27 to the x, 1 over 27. I'm not really sure where to begin necessarily, so I might just try with the smallest number here and see if I can make powers that work for all these. So 9 to the 1 is 9. 9 squared is 81. That jumps right over 27. So that means that 9 is not going to work for me. I also know that I can write 9 as 3 squared. And if I did 3 to the 3rd is going to be 27. Okay, now we're in good shape. I've got one for that one. I've got one for that one. For 1 over 27, I know that it has to be a negative exponent. So that's going to be 3 to the negative 3. Okay, so I'm going to write this as 3 squared to the x plus 1. I'm going to keep the things I'm substituting in blue just so they look different. 3 to the 3rd to the x, and then 3 to the negative 3rd. All right, using some exponent rules, we know we got powers to a power. That means that those things are going to multiply. So we've got 3 to the 2x plus 2 multiplied by 3 to the 3x is equal to 3 to the negative 3. And using exponent rules again, if we're multiplying two things that have the same base, it means we're really adding those exponents. So when I write this equation, I'm going to write it down below just as the exponents. 2x plus 2 plus 3x is equal to negative 3. I'm going to combine my like terms here. I got 5x, move the 2 to the other side, is equal to negative 5. And that tells me that x is equal to negative 1. I'm actually kind of shocked that I came out with such a nice number. That doesn't usually happen if I choose random things. All right, next we've got to solve some using logs and exponentials together. This is using the same, perhaps the biggest idea we talk about this year in algebra, which is we have to get the function or the weird thing by itself and then work on solving stuff. So I'm going to get log base 10 of x minus 4 by itself. To do that, I'm going to minus 5 to both sides. We've got 3 log base 10 of x minus 4 is equal to 9. I'm going to divide both sides by 3. We've got log base 10 of x minus 4 is equal to 3. Here I see a lot of people stop not really knowing what to do, but at this point we're going to convert to exponential form. And the big idea here is that if I've got some kind of base to an exponent is equal to what we call the argument, then the log form of this is going to be log base b of that argument is an exponent. What we're trying to do here is to go from the log form to exponential form. So in this case, that's going to be 10 to the 3, that's my base and my exponent, is equal to x minus 4. 10 to the 3 is 1,000, is equal to x minus 4. That means that x is equal to 1,004. All right, then next up, we've got, I'm going to go, I guess, to the next one because it's an exponential. 3 times 4 to the x minus 5, and then that looks like a minus 11. I kind of wrote over that, so I'm going to box that. That's what we're trying to get by itself. I'm going to add 11 to both sides, and we get 3 times 4 to the x minus 5 is equal to 33. Okay, now I'm going to divide by 3. 4 to the x minus 5 is equal to 11. At this point, again, a lot of people are stopping, but here we're going to do some converting, and we're going to go backwards. So we're starting from exponential form, so that's my base, my exponent, my argument, and I'm going to write this in log form. So log base 4 of 11, and that's equal to x minus 5. As a last step, we're just going to add 5 to both sides. One of the things I really like that I've seen some of you do is put the parentheses around the inside, because that makes us less likely to try to combine the 5 and the 11, which are separate from each other. So we've got log base 4 of 11. We keep that in parentheses, plus 5 is equal to x. At that point, we are fully done with that. I switched page. Next up, we've got exponential models. Same thing, I'm going to look on the left side, and actually it looks like I'm going to do the top two. I'll save the Mr. Butterworth and the tardigrades, which, by the way, are called water bears, and they're fascinating creatures that may be immortal. So there's a lot of things about that. They're also featured prominently in both Ant-Man, Ant-Man 2, and I think we see them again in Avengers Endgame, and I don't think that's actually a spoiler because tardigrades are not an important part of the plot. But for the first one, we're looking at ladybugs in the Ladybug Hotel. And what I'd like us to remember is that we have a general form for these things where we have the final amount is equal to the starting amount multiplied by some kind of scale factor, what we call the rate number, to the time, and then divide by the length of a cycle. So if I look here, 2 would be the starting amount, 3 would be kind of the rate, so we're multiplying by 3 each time, and 4 would be the length of a cycle. So now that we've broken some of that down, so when the hotel was built, the starting number, 2 ladybugs lived there. The population increases by a factor of, this is my rate, so if I see that, and this is not a rate in terms of percent, this is a rate of tripling each time. So we say it's a factor of 3, and this should be every, that's a nice typo, and the cycle length is going to be 4 for 4 months. To figure out how many ladybugs there will be in 3 years, the first thing I need to know is that 3 years and 4 months are not compatible numbers. I know that there are 12 months in a year, so this would be 36 months. I'm going to plug that in. So b of 36, that's what we're plugging in for t, is equal to 2 times 3 to the 36 over 4. That's going to be a really big number. So 2 times 3 to the 9th. 3 to the 9th is going to be an absurdly large number. I'm not going to actually figure this out, although now I'm kind of tempted. So I threw this on Desmos, and 2 times 3 to the 9th is going to be 39,366. So after 3 years, there'll be 39,000 ladybugs in that ladybug motel, which, by the way, is fantastic for your garden. Ladybugs are predatory and eat things that are problematic, most notably aphids, which will literally suck the moisture out of leaves. Interestingly, if you spray them with neem oil, which smells like a mixture of cloves and citrus, the aphids will also die, which is helpful. For the next one, we got the number of books in Miss Ankatel's library, which is growing exponentially. She had 17 books, but every 2 months it grows by 20%. So we've got to write an exponential model. Every 2 months, that's going to be my K value. That's the cycle length. Grows by 20%. I want this to be 1 plus 20%, in other words, 1.2 for my rate. And then we got 17 books, that's my p-value. Okay, so plugging that in, we've got 17 times 1.2, and then to the time over k, and that's, 2 instead of k, and I want to make sure I know that that's months. Because, after I mess with you, we're going to have 5 years, which is 60 months, and 10 years, which is 120 months. So looking at this, plugging these things in, we're going to have A, and I'm going to call this A of 5, is going to be 17 times 1.2 to the 60 divided by 2. So 17 times 1.2 to the 30. And if you don't have a calculator, I'm totally fine with you leaving that like that. Although it's a little bit more challenging for me to see what's going on. And I just totally messed this up. There we go. So after 5 years, she has 4,035.4 books. I'm not really sure what that means. Again, these are just models, so we could be talking about somewhere in the neighborhood of 4,035 books. A of 10 years, and really this should be 60, not 5. That's what we're plugging in. So 120 would be for the next one. So 17 times 1.2 to the 120 over 2, which is 17 times 1.2 to the 60. And if I do 1.2 to the 60, I'm actually really excited about this number. Ooh, and this actually helps us with the next one. So we get 957,907.7 books. And interestingly, if we're looking for 1,000,000 books, we got really 2 ways to do this. One is using the guess and check method. And I might look at this as we get really close here. If I wanted to get to 1,000,000, maybe I want to make this 61 instead. And if I plug in 61, we get just over 1,000,000. So if I plug in maybe 60.5, we get even closer to 1,000,000. 60.25 is going to be even closer. I'm just plugging in numbers and seeing what I get. 60.2 is a little bit too small, so I'm going to go with 60.25 as the closest I can get. And then I'm going to work backwards. So 60.25, to get that, I'd have to have 120.5 is equal to t, and that's going to end up being 10 point something years, so it's 0.5 over 12, which is 1 over 24, which is a little bit more than 0.04. 1 divided by 24, 0.042. The other option we have is to do this using logs. And if we're looking at this, that's going to be 1,000,000. I did not put the comma right. There we go. And that's going to be equal to 17 times 1.2 to the t over 2. The way we do this is divide by 17. So if we've got 1,000,000 divided by 17, that's going to be 58,823.5 is equal to 1.2 to the t over 2. I'm going to make both sides log base 1.2. So log base 1.2 is going to be 58 823.5. That's equal to t over 2. Multiply both sides by 2. So 2 log of 1. Sorry about that. 2 log base 1.2 of 58,823.5 would be your final answer. And if you have a calculator that can do that, what we do is we do log base 1.2 of 58,823.5, and that's going to be times 2. And when I do that, I get 120.47 is equal to t. Based on what we had, 120.5, we did a really good job with guessing and checking. Nice job. Next up, we've got right triangle trig, and just as a reminder, this is graded this time. It's not usually the third section graded, but this time it will be. So please be aware of that as you're studying, getting ready for this. First thing we'll do is start with A. I'll use different colors for each triangle, and we've got an opposite side, a hypotenuse side, and my adjacent. It might be useful for me to figure out what my adjacent side is. Here we've got the pieces for sine and for cosecant, but we don't have stuff for the other ones. So I know that's going to be a squared plus 5 squared is equal to 8 squared. A squared would be 64 minus 25, which is going to be 4439, which means that A is equal to the square root of 39. Okay, sine of A, that's going to be opposite over hypotenuse, which we already had, 5 over 8. Cotangent of A, I know cotangent is the reciprocal of tangent, which is opposite over adjacent. Again, I'd like you to notice that these are all written at the top of the page. For the regular ones, you need to know which reciprocal goes with which. So that means that cotangent is going to be adjacent over opposite, which is going to be the square root of 39 over 5. And then secant goes with cosine. They go with the wrong letter. But this is also cosine of B, so I'm going to switch up things in a second. All right, so I'm going to switch my stuff for B. I'm going to do B in yellow, I think. That means that this is now the opposite. This is the adjacent. This is still the hypotenuse. Secant of B would be hypotenuse over adjacent. So in this case, that's going to be 8 over 5. Okay, the next part asks us to solve for measure A. That means we're looking for this. I'm going to switch back to blue. I'm looking at this with respect to A. And here I know my opposite and my hypotenuse, so I'm going to deal with sine for this. So sine of A is 5/8. That means that to get the angle, I've got to use inverse sine. Sine inverse of 5/8. And when I do that, I'm going to, by the way, if you don't have a calculator, you can leave it like that. But if you'd rather know what this is, I'm going to do this up on Desmos for us to see. Sine inverse of 5/8 is 38.7 degrees. Okay, so the shortest way for me to get B would be to just use what we know about triangles, which is that we've got 180 degrees in total. If we take away 90 and then take away 38.7, that leaves us with, sorry, that should be A. For B, we've got 51.3 degrees. And we already found AC. We did that at the beginning of the problem without even realizing that we were going to need that. All right, for the next one, we've got a tiny but horrible alien standing at the top of the Eiffel Tower. And a Men in Black agent. By the way, the new Men in Black movie is coming out this year, starring two people who are really amusing to interact with each other because they were excellent in both Thor Ragnarok and Avengers Endgame, which, by the way, second Avengers Endgame reference in this review. It's a shame that a bunch of you don't actually listen to this with the sound, because I think I'm really funny when I'm talking. Okay, so we've already got this thing built and labeled, and this agent is aiming his laser gun at the alien. So the question is, what angle should the agent aim their laser gun? And here we've got 324 and 54. That's going to be, based on this angle, my opposite and my adjacent. So we might say that tangent of question mark is equal to 324 over 54. And just like before, we know that we need to do inverse tangent of 324 over 54, and that would tell us that angle. Again, don't have a calculator, leave it like that. But that's not a useful thing as far as knowing what angle that is for most of us. Certainly not for me, I don't know what that means, but 324 divided by 54 is going to be an angle of 80.53 degrees. Lovely bell there to end the trig stuff. And finally, we got our new stuff. We've got law of sines and cosines. I'm just going to do the ones on, I guess I've got to do the top set, and then I'll do one of the two ones down below. So for the first one, it's asking us to use law of sines. I told you that I'd let you know which one to use to solve for AC. AC is this other side. We also call that lowercase b. I'm going to look to see what I have. I've got both parts for A. That's nice. So sine 23 over 7. And for B, we've got sine of 71 over the variable b. Okay, I'm going to do this out. Sine 23 divided by 7 is going to be 0.0558. I feel like we did this problem in class. And sine of 71 is going to be 0.9455 over b. Multiply by b to both sides. Whenever I have a variable in the bottom, I need to make sure that I get it out of the bottom. And when we do that, we get b times 0.0558 is equal to 0.9455. Dividing both sides by 0.0558. And that gives us a b value that is going to be 16.94 as our final answer. All right, using law of sines, and here we're trying to solve for the length of AB. You might also notice that that would be called lowercase c. Here we've got B is 7 and A is going to be 8. For law of cosines, I want to use whatever formula gives me the value I need. That happens to be the one that we have written here. So we've got c squared is equal to 6 squared plus 7 squared minus 2 times, I feel like we did this one in class also, 6 times 7 times cosine of 59. And when I type that in, so that's going to be 6 squared plus 7 squared minus 2 times 6 times 7 times cosine of 59. Again, literally just typing that in as is. Hopefully you have a graphing or scientific calculator that you can see what you're typing. That makes this so much easier. And when you do that, you should get c squared is equal to 41.74. If you don't have a scientific or graphing calculator, you've got to do each of these three pieces separately. Then you get 36 plus 49 minus whatever this is. You cannot do that all together. It will not do order of operations correctly and make that really hard for you to get a valid answer. When I take the square root of both sides, we end up getting, so square root of 41.74, 6.45. I will do the other law of cosines one because that's asking us to solve for an angle. And here we're looking for angle A. That means I want my law of cosines to start with A squared. So just if you get caught and you've got to build this by yourself, what we're really doing here is in the formula up above, we're swapping our A and our C. So anywhere that we see an A, we're going to write a C. And any case that we have a C, we're going to write an A. So A squared is going to be C squared plus B squared minus 2 times C times B times cosine. Instead of C, I'm going to write A. Plugging stuff in. A is going to be 6, so 6 squared. C is 14, 14 squared. B is 12, so that's going to be 12 squared minus 2 times 14 times 12 times cosine of A. And here we have to be really, really careful. We're trying to get cosine A by itself. So what that means is that we've got to move the other stuff to the other side. And that we've got to kind of simplify some things first. So I'm going to do this as 6 squared is 36. 14 squared is 196. 12 squared is 144. I'm going to do this as 2 times 14 times 12. And that's going to be minus 336 cosine of A. The trick is we cannot combine the three numbers on the right side. We could certainly combine 196 and 144, but we're going to minus those to the other side. So if we did 36 minus 196 minus 144, this is going to end up being negative 304, is equal to negative 336 cosine of A. To get cosine A by itself, we're going to divide by negative 336. And when we do that, so negative 304 divided by negative 336, we get 0.9048 is equal to cosine of A. To get A by itself, we're going to convert that to cosine inverse on both sides. We need the angle. So 9048 is on the inside. And when we do that, we get A. Again, no calculator, although you would not have gotten to this point as far as decimal without a calculator. So if we do arc cosine, 0.9048, we get A is equal to 25.2 degrees. All right, looking here, I'm going to look at the next one. That sounds kind of fun. So we've got a robot with Ariana and Raphael. I'd like to think about him as a Ninja Turtle, or maybe her. I don't want to judge the name. So I'm going to draw a nice face for my Ninja Turtle. And we're using the law of cosines and law of sines. And what we're trying to do is to figure out what distance is here. Most of this story we don't actually need to know, and they also give us a picture that's pretty clear for us to figure this out. So looking at this, I've got a 120-degree angle there. That's called the outside angle for this. And what we really need to figure out is what this inside angle is. The other piece of geometry that I hope you remember is that anything that ends up being a line is going to also sum to 180 degrees. This would be what we call a linear pair, and that would leave us with 60 left on the inside. I'm going to check law of sines first, and I don't have enough very quickly. So we're going to use law of cosines, and I'm just going to label things A, B, and C. And here I'm looking for C. So I'm going to use the C version. C squared is equal to 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of 60. So C squared is going to be 16 plus 9. and that's going to be 2 times 4 is 8, 8 times 3 is 24, cosine 60 is a half, 24 times a half is 12. Again, you can just plug this into calculator and you're good. 16 plus 9 is 25, minus 12 is 13. C is going to be equal to the square root of 13, which is somewhere bigger than 3 and less than 4. And what the heck, I already have this open, I might as well. Which is 3.605.